Hello students, welcome to my YouTube channel Easy Mathematics. In this video, we are going to discuss about the Raabe's test, which is again a very important test after the D'Alembert's ratio test. Because whenever D'Alembert's ratio test fails, we first apply the Raabe test after that. Anyway, so at first the statement of the Raabe test, after that we discuss the other features of it. So the Raabe test is when a positive term series is expressed in such that limit n tends to infinity, n into un by un plus 1 minus 1, where un and un plus 1 is the n and the n plus 1th term respectively. If this limiting value is equals to L, then the series is said convergent if L greater than 1 and divergent if L less than 1. And definitely the test fails when L is equals to 1. So sometimes this Raabe test is called the Gauss test also. Actually, Gauss test is the generalized test from where we can derive this Raabe test. So anyways, what is Gauss test in general, that we discuss later on after this video. Right now it is the Raabe's test. So first of few things which we should note for this Raabe test is, the number one is, I already told you that when D'Alembert's ratio test fails, then first we apply Raabe test or Gauss test. And if un and un plus 1 does not contain the number e, just remember, when the limiting value un by un plus 1, this one, if it does not contain the number e, that means the expression of the kind 1 plus 1 by n to the power n, then we apply the Raabe test, otherwise not. So now, if the D'Alembert's ratio test fails and un by un plus 1 contains the number e, then we apply logarithmic test. So look, if in the Raabe's test, if we are going to apply the Raabe's test, then we just verify that un by un plus 1 containing the number e or not. If e contains, then we apply logarithmic test. That is another test that we will discuss later on. And if it does not contain e, then we apply the Raabe test without any doubt. So one more thing, that the Raabe test fails when we apply, that is when the Raabe test fails, that means when the limiting value we will find out 1, that time we apply De Morgan's and Barton's test. De Morgan's and Barton test. Now after that, one alternative statement for the Raabe test we can say as un by un plus 1 is greater equals to 1 plus alpha by n for alpha greater than 1, then the series is convergent, and if un by un plus 1 is less than equals to 1 plus 1 by n for any m, for all n greater equals to m, then the series is divergent. So this one you can see as the alternative statement for the Raabe's test. Actually in the Raabe test we have the limiting case we consider in this way, n into n by un plus 1 minus of 1. So that we can write is equals to L. So L we can say alpha or something 1, whatever we want to consider. So 1 in this we can take in this side, and after that this one we take in the right hand side, so that un by un plus 1 is equals to, in general we can write 1 plus of L by n, or that L may be your alpha, maybe your 1, depending upon the situation. So this one is probably this alternative statement we will come from here. Actually this alternative statement we shall derive from the Gauss test, which is the generalized form of the different tests. Now we go for some example. This Raabe test also we understand with some examples. So let us start the example so that we can understand what is Raabe test and when to apply. So the first question is, discuss the convergence of the series 1 plus 1 by 2 into 3 plus 1 into 3 by 2 into 4 into 5 plus in this way. So here the definitely un is 1 into 3 into 5 into 7. It is up to 2n minus 3. And the denominator is 2 into 4 into 6 into 8. In this way it is 2n minus 2 into 2n minus 1, where definitely n is greater equals to 2. because n is equals to 1 for, we will not get the definite. So, and one thing, we should omit the first term here. We should omit the first term here, because we know after deletion and subtraction of few terms from a given infinite series, it will not affect the nature of the series. That's why we omit the first term, and second terms onward we will have this un, so that this un is validate for n greater or equals to 2. Now from here we should find out un plus 1. So definitely in un, just substitute n for n plus 1, and whatever be the value you will find out, that is your un plus 1. Now we take the ratio of these two. So at first we take un plus 1 by un. Why we will do so? Because in D'Alembert's ratio test we will find out so. So if we will do that, then we will find out this one, and while we take the limiting value, then we will find out this is our value is 1. So D'Alembert's ratio test, this is the application of D'Alembert's ratio test, and while we apply the D'Alembert's ratio test, that value is 1, means D'Alembert's ratio test fails. I just want to show you only that if for any given series, we at first apply the D'Alembert's ratio test. If D'Alembert's ratio test fails, then we go for the Raabe test or the logarithmic test. So depending upon that, the content, it contains the value e or not. Anyway, so here when this one is 1, we say that D'Alembert's ratio test fails, and we should apply for the Raabe's test. So now when Raabe test for n into un by un plus 1 minus 1, that value we should find out. We already have calculated un plus 1 by un. So if we take the reverse of this one, that means if we take the reverse of this one, then we will find out un divided by un plus 1. So accordingly, if we substitute here, then we will find out this one is equals to n into here, just by inverting this one, we will find out this one minus of 1. If we simplify and take the limit, then we will find out the value is finally 6 by 4, that is 3 by 2, and which is obviously greater than 1. Hence, by Raabe's test, the given series is convergent. Now one more example we should do for this one. So here the series is 1 plus 3 by 7 into x plus 3 into 6 by 7 into 10 into x square in this way. So here also again we find out the un. Here again we just omit the first term to get the un, and un is 3 into 6 into 9 into 3 multiple of n, divided by 7 into 10 into 13 into, in this way it is 3n plus 4 into n x to the power of n. And from here we can easily find out un plus 1. After getting these two, we take the ratio un plus 1 by un just to apply the D'Alembert's ratio test. So this ratio value, we will get this one. So while we take the limit, then we will find out the value is x. So by D'Alembert's ratio test, we say the series is convergent when x is less than 1, divergent if x greater than 1. But when x is equals to 1, the test fails. So when we substitute in this un, the x is equals to 1, and then we apply the Raabe's test, so that we will find out here, after that substitution, this limiting value is 4 upon 3. So this value is definitely greater than 1. Hence the series is convergent. So by Raabe's test, we can say when x is equals to 1, then the series is convergent. So final conclusion is that the given series is convergent for x less than is equals to 1 and divergent for x greater than 1. So that's all for this Raabe test, and I'm not giving you any question here for do by yourself, because whatever be the question you will find out in the D'Alembert's ratio test, if that one fails, instead of the comparison test, you should apply this Raabe's test, provided your un by un plus 1 contains the quantity e or not. So how we will find out that? If your ratio un by un plus 1 contains the series of the type n 1 plus 1 upon n to the power n, so that type of thing will be there, means it will contains the term e, otherwise not. So if it will contains the term e, then we should go for the logarithmic test, which we yet not discuss. We discuss on our upcoming video. And if it doesn't contain any e, then we should go for the Raabe test. So whatever be the do by yourself questions are given in time of D'Alembert's ratio test on that video. That all questions you should practice for the Raabe test. Okay, I hope you can understand. So have a nice day and thank you all.